Thanks for coming for the talk. My name is Kiran. I've been with ThoughtWorks for the last 14 years, and I'm a dev and a principal engineer at ThoughtWorks. These days, I work out of a Berlin office.
And my name is Lucy. I'm a product consultant. I've been at ThoughtWorks for 18 months. Basically the fact that we're consultants is one of the reasons that we're doing this talk, because we've seen what we consider to be a little bit of an epidemic in the software industry. Because we're consultants, we get to see lots of different clients, and we've seen this over and over again. And Kiran and I actually wrote an article with the same title as this talk and tweeted it around. And some of the feedback that we got was that the problem that we're about to describe is one of the biggest problems plaguing the world of big data, and people trying to get software projects off the ground. The problem, in a nutshell, is that lots of organizations are trying to turn themselves into a data-driven culture. And that's a kind of a seductive thing to do. Our monster, if you like it, is a seductress, maybe a siren. They think that the way to do that is to get all of the data that they have in a particular place and make sure that everybody can use it. So it's framed like a technology problem. But the spoiler of what we're going to talk to you about today is that this is by no means a technology problem. This is an organizational problem. This is a process problem. And this is a philosophy problem of how you approach your projects. And Kiran is going to tell us a little bit more about why.
So let's start with what is a data lake and why do organizations go about building them. Data lake is a centralized repository of both structured and unstructured data. Its predecessor is data warehouse, which was meant to store only the structured OLTP data. So this is for both structured as well as unstructured. When organizations go about building them, their intent is democratization of data. What does that actually mean? It means that the thinking goes that once we have the central infrastructure we collect all the data from our transactional system in there, which the companies think the data itself is like very inherently valuable, and because data is the new oil, right? Once we have this in the central infrastructure, the people who within the organization who wants to build useful stuff with it can easily discover it and do something useful with it. That's the intent when organizations build this data lake. So this is how most data lakes look from 10,000 feet above. It almost always has this ingestion function, which is basically tapping into all of these transactional systems and collecting the data. And there is a platform itself which does the cleansing and the aggregation of this data. And then you see the third piece, which is basically serving this data and making something useful out of it. So while many organizations are investing heavily in this data infrastructure, very few of them actually succeed. I was reading this recent survey by New Vantage Partners, who surveyed many CTOs and CIOs, that over 50% of them deem that the investment they're making into the data infrastructure is not actually producing the value they're expecting for it to produce. Why is this the case? Why do most of the data lake project end up being a failure? We think there are two main problems. We're going to talk about both of them, and also we're going to talk about what we can do about them. The first problem has to do with the framing of the problem itself. As Lucy was saying, a lot of the times we see that the problem is framed as an infrastructure or a technical one to which the data lake is the answer. So we call it the build it, they will come pattern, or rather anti-pattern, right? We've seen the organization falling for it like time and again, and for some reason data lake seems to be particularly susceptible to it. So the thinking goes that, so let's have all of these data coming in from our transactional system, and let's dump into this central data lake. Let's figure out how to actually process these gigabytes or petabytes of data, how to actually optimally represent them. And basically, once we have this piece of infrastructure nailed down, the hope is that like somebody will come along and do something useful with it. But our observation that is this is at best wishful thinking. I think Neil was pointing to it in his Q&A session this morning, that it almost never pans out this way. Because without being intentional about what are we going to do with this data, whom are we building these applications for, and how they're going to use it, it is very difficult to sort of see the end of it, see the end of this sort of infrastructure project. And a lot of the time, when organizations start with this kind of a framing, they end up with this over-engineered mess, which doesn't add any value to anybody. So coming to the second problem, which is about how this data lake or data infrastructure is architected. So most of the time, this is architectured as a centralized data agnostic monolith. While the success of the microservices and DevOps has shown us that for our operational system, it's a good idea to have these smaller teams organized along our business capabilities. When it comes to data infrastructure, we seem to have a blind spot. Almost always, it is designed as this big monolith. Now, if you're an organization of small size, this is not a problem. This works perfectly well. But once you grow beyond a certain size, like a medium or a large organization, it's very easy to see where this starts falling apart, right? There's going to be like a proliferation of these sources and consumers, and if there is one team who's responsible to sort of make sense of this data which is coming along and then have to represent and make use of it, it's very hard for them to keep up. They just cannot sort of comprehend all of this sort of complexity and do the optimal thing. And this also follows like how the framing of this as a technical problem also sort of affects how the monolith gets decomposed. Quite often, we see that it gets decomposed along the technical lines, right? So there is an ingestion team, which is basically made up of engineers who can understand these event streams, Kafka streams, and stuff. And then there is this processing or aggregation team who are well-versed with writing MapReduce jobs or Spark ETLs. And then there is this serve team, which is sort of made up of data scientists or backend engineers who are kind of writing these APIs and exposing the functionality. Now, what is the problem with such decomposition, right? Think about if you have to roll out new features and capabilities. Basically, all of these three teams need to sort of coordinate, their backlog needs to coordinate to ship out a new feature, basically. So here, your unit of change is data lake itself. As I said, like for a small organization, if you're kind of planning to optimize the utilization of developer time, this is probably a decent architecture. But if you're a mid or large size organization and your focus is to do things faster, which is flow efficiency, right? Like basically being able to ship out the capabilities and the features faster, this architecture is not going to work. So in effect, what I'm saying is like if you want to be truly agile, that if you want to come up with a hypothesis and being able to test it quickly, scale the ones which work and discard the ones which don't, and if you're of a certain size, you need to sort of think about doing something else other than creating this big monolithic data lakes. Otherwise, you end up sort of with the risk of creating what we call data swamps, which is basically this infrastructure where the data and the information only gets in and nothing of value gets out, and you end up sort of spending millions of dollars on this. And then we come to the central point of this talk, like how can we do better, right? So one of our senior technologists called Zhamak Dagani, she's from North America. She had this brilliant insight. She wrote a blog post about it, which is on the martinfowler.com. We're going to link to it at the end of her slide. She came up with this term, the data mesh paradigm. It turns out we don't have to invent new things. We just have to apply what we know from the success of microservices, DevOps, and product thinking, and apply that to the realm of data. What does that mean? Like, we're going to spend the rest of the talk sort of explaining this concept and see how it works for the data. So in short sentences, product thinking is about how to think data as a product in itself and build towards some business value. And domain-driven design is about having smaller autonomous teams who are built around like a specific business capability, and they depend on other such smaller teams to do something bigger. And platform thinking is about how to create this self-service platform, which makes the working of the domain teams, smaller domain teams, much easier and smoother. With that, we go to the next section. I'm going to hand it over to Lucy, who's going to talk about what product thinking is and how it applies to the data project.
Excellent, thank you, Kiran. One of the things I like most about data lakes is how far you can stretch this metaphor. So if it gets a bit tedious at some point, let me know. But yeah, you can't move fast through a data swamp. Nobody's going to be going very fast. So yeah, just very quickly, I wanted to get everybody on the same page about what Kiran and I say when we say product thinking, because there are lots of different definitions of it. But in this particular scenario, we mean something quite specific. And the easiest way to understand what we mean by product thinking is to contrast it with another common mode of delivering a project, which is kind of project mode. So project mode and product mode, we're going to contrast. And one of the key differences in the two modes is how they start and how they stop. So when you're in project mode, you tend to have defined your solution up front. You know roughly what you're going to build. You kind of know what team you're going to have and how long you want the project to run for. Obviously discounting overruns and whatever. In product mode, maybe you don't know the solution up front. You know what the problem that you're trying to fix up front is, but the solution is something that you recognize that you have to work out as you're going. And both of these have implications for when you stop the project, because in project mode, you stop when you've delivered the thing that you set out to build. And in product mode, you stop when you have actually fixed the problem that you set out to fix. So the reason that we advocate for product mode is because does it really matter if you shipped all of those features if you didn't actually fix the problem that you set out to solve? I think not, but fight me afterwards. And the focus is also different. So when you're in project mode, you'll tend to be talking about things, features delivered for a given time and on a particular budget. That doesn't mean that we stop caring about those when we're in product mode. We obviously care about speed and we care about how much money we're spending. But the thing that we care about more is making sure that we can deliver value fast. So the way that we check that we're delivering value fast is to have a look at business goals. So those are the main things that we're focusing on. So we look at the business goals and we look at the metrics and we work out if the things that we're delivering are actually getting us any closer to that thing. And so yeah, you can kind of see that the scope has to be dynamic in the second mode, because you have to keep being resourceful and coming up with a plan until you fix your problem. And so you can see how these data projects quite often fit into project mode. Like the person has decided up front that the thing that they need is a data lake, and that's going to fix all of their problems, and then approach it for the next couple of years and X million euros or pounds or dollars, making that thing happen and then being disappointed that it doesn't happen. We're going to go a step further in terms of defining product. Maybe you're really lucky, maybe you're working in an organization that already does product. You would probably be the anomaly, but if you are managing to do this, congratulations. But typically the things, even for companies that are already working in product mode, they usually think of themselves as delivering particular business capability. So their job is to perform some kind of task, quite often for an external user to allow them to do a particular thing. We're going to make their job a little bit more difficult in this sense, because we're going to give them a second job, and we're going to ask them to own also the domain's data for the benefit of the rest of the organization. So now they don't only have external stakeholders, they also have the internal stakeholders as well. And it's their job to care for and curate that thing as if it were a product in its own right. And the benefit of this versus the model that Kiran was talking about, where you have the central data platform in the middle and a platform team, is that the people who are actually producing this data are the people who know it best. So they're probably going to be more efficient at doing that job anyway. And so whenever you talk about products, you usually talk about some kind of desirability characteristics. And there are some, this also comes from Zamek's article, there are some which are kind of commonly attributed to data products. So the things that this team probably has to care about is they have to make sure that the data that they're producing is actually discoverable. There are many ways you can achieve that goal. Doesn't have to be a data lake. It could be some kind of data catalog. It could be some excellent system of having data librarians. It has to be addressable programmatically, so programmers have to be able to find it and they have to be able to access it, because these teams are independent. So you want to make sure that they don't have to come and knock on your door and download this thing somehow every time. Trustworthy, no one's going to use your stuff if they don't know how it was produced. So this team has to kind of own the provenance of that data and really make sure that it's up to the level that the business needs to be. Self-describing, again, autonomous teams. You don't want people to have to come and ask you questions every single time they use that data. Interoperable, because presumably the reason that they want to use your data in the first place is that they want to combine it with other things. So it's helpful if they kind of conform to some generally agreed on standards. And secure, because you only want the people who are meant to have your data to actually have it. And just before I hand back over to Kiran, the reason that we advocate for these kind of product quality things is because they help you check whether you're on the path to creating some kind of undesirable state, like having a data swamp. Because this probably makes some sense to people in the UK. I'm probably going to have to translate it in the other locations where we do this. But there's a saying from some unknown philosopher, like if a tree falls in a wood and no one's around to hear it, it doesn't make a sound. And exactly the same thing goes for a data lake. Like if someone puts data into a data lake and no one can find it, is it even there? Like we just don't care. So you have to ask yourself, does it even make sense for me to be investing time curating and cleaning all of this data if nobody's actually going to be using it, because it's basically swamp pollution. And with that, I'm going to hand back over to Kiran to talk about architecture.
Thanks a lot. So once we're comfortable with the idea that the data set can be product in itself, the next question is about how do you go about architecting this data platform for agility and flow efficiency. So this is what we're calling the data mesh architecture. So there are two principal sort of components to it, basically the learnings from the microservices and the DevOps movement and how we apply to data. The first is about domain-driven design, which is how do we think in terms of like smaller teams who are sort of aligned with the business objectives, doing their sort of own thing to produce this data products which Lucy was talking about, instead of having one big data platform team, right? The second one is about how do we create these self-service platforms, which is going to make the life of these independent autonomous teams simpler and make them incredibly easy to create these data products. So the first aspect is the distributed pipeline, which means that there are independent teams, they have their own data pipeline. So here, the data pipeline is not a central thing. It is just an implementation detail within each of these teams. They're going to do their own sort of input, cleansing, aggregation, and also creating products on top of the data. And then basically, just like in microservices team, we have these APIs and contracts and SLAs between the teams who are sort of loosely coupled. Even in this case, right, there is clear definition as to sort of what format the data is stored in and where it is stored in, how easy or difficult it is to sort of discover it, how often the data is updated, right, and what is the SLAs for if you find some inconsistencies in data, what is the SLAs for actually fixing it. So we can have like a common governance across all of these smaller teams. But the central point being like we're not talking about one central monolithic data lake, but multiple smaller ones, and the focus here is on shipping the product rather than sort of these technical problems of ingesting petabytes of data, running MapReduces on them, and then thinking about like what is the optimal use case for all possible future scenarios. We're also saying like that doesn't mean that we go back to a world where each of these teams has their own sort of relational data, transactional database, and team A is going to directly reach out to the transactional database of the team B and read it, right? Like we're not sort of advocating for like anarchy here. So once we have that sort of independent teams and common governance model, we can sort of abstract up the common functionalities they need into the self-service platform. Anyone who is doing this such data processing is going to need a storage like a HDFS or AWS S3, and they're going to need this computation in terms of data locality and data pipelines. They're going to need data catalogs for making other people to find their data very easily. And then you go to have to figure out encryption and archiving. So all of these things can be abstracted as a self-service platform. The keyword here being self-service, right? So you don't want a scenario where if I want storage or computation, I'm going to raise this Jira ticket and I'm going to wait days or weeks before I have it. So with the public cloud which are primarily self-service, it is actually possible to do this right now. Keith was talking about some of these aspects this morning when he talked about evolutionary approach to infrastructure. So bringing it all together. So basically, this is what we're calling the data mesh architecture, where you have these independent teams who are working on their own data products. They're all using the facilities provided by this thin data infrastructure, which is based on self-service. And then there is an overarching governance, which is hopefully based on open standard, which is basically the commonly agreed upon rules as to all of these teams need to conform to. The big point here being like the focus shift from purely technical terms of like how to store the data and how to crunch it to sort of providing value, like shipping products and providing end user value. That's the key difference here. With that, I'm going to hand over to Lucy, who's going to talk about how this can be implemented in a hypothetical company.
In a hypothetical one, excellent. Insurance companies seem to be very popular examples for data lakes. For some reason, we hear them talked about a lot. But yeah, it works quite well in this case. So I'd like you to imagine a big insurance company, insurance company that's kind of eaten a lot of other insurance companies and bought them up. And what they realize is that in order to move forward with a lot of different things, they need to know a lot more about their customers than they currently do. And that relies on them being able to build an accurate picture of what a customer is. But because they've purchased all of these smaller companies, all of which have their own individual systems, it's very difficult for them to get an accurate picture of what a customer is. They can't put together things like, has customer A bought car insurance and home insurance from us? But because they are our poster children, they are in product mode. And instead of dumping all of this stuff into a data lake and hoping that particular teams can work it out, they set themselves some business goals. And they focus on a couple of things that they want to achieve. The first thing is that they think that they can save the company a lot of money by identifying fraudulent claims, and they set themselves a goal of reducing fraud by 5% a year for doing that. They also have a hypothesis that they can save themselves money in the car insurance section if they offer a service that predicts weather patterns and sends their customers an alert that they have to bring their car inside if the storm is coming. That's their second thing, and their hypothesis is that they can save the amount of money, reduce the amount of money by about 2% per year for that. And then the kind of grand pièce de résistance is that they want to be able to upsell. And at the moment, they don't know. They don't know, has this person already bought car insurance or are we trying to double sell them? And they think they can up their conversion rate by 2%. So they're already doing an excellent job. And now we go to how they actually go about that. And they start with the fraud detection case. And instead of dumping all of the data that they have from all of the different parts of the organization into a data lake, what they realize is that probably they can hit the 5% business goal just by looking at a couple of verticals. So they take the customer and claims data from the health vertical, and they take the customer and the claims vertical from the vehicle vertical, and they put that into play, into the data lake. And these bits, these purple bits up at the top, these are autonomous teams up here. And so they're working with their own representation of the customer and the claims. And they can do exactly what they want with that because they're not touching the original data. And it happens that they come very, very close to hitting the 5% goal with that, but they don't quite make it, so they add house data. And that's great. Good work, everybody. So they move on to the upselling use case, and I should make clear that we're not saying that these have to happen one after the other. These, because they're independent teams, they can work in parallel. But yeah, in this particular case, we kind of see that the first case can inherit some things from the second one, but they don't rely perfectly on the same representation as the first case. So all they have to do in the second case is add some product data to the data lake, and again, they've only got things in the data lake that they actually need to be using. And then the alerting case carries on in the same fashion that the other use cases have, and they add the weather data. And let's assume that they hit all of their business goals and everything is wonderful in this particular case. But even if they don't, they haven't wasted a huge amount of effort cleaning and processing and storing data that they don't need. And at least they can check quickly whether they can hit, because they've got clear goals and they know when they're going to stop when they hit those goals. So just to wrap things up, being data-driven is not a technology problem as far as we're concerned. Obviously, there are some mindset shifts, but there are probably also some organizational shifts that you need to make. You need to make sure that your teams are set up in a way that they can actually deliver on particular business goals. Domain data is a product in and of itself. You should look after it. You may even want to consider doing things like user testing in the same way that you would do with other types of product work, and focusing on delivering business value. Just make sure that you're not building things that you don't necessarily need.
Yeah, and third important takeaway, which is basically if you're a mid or a large size organization, do think about this data mesh architecture instead of creating this one big monolith. Think in terms of like, can we have independent, smaller autonomous teams who are focused on creating business values instead of just purely solving these interesting engineering problems of how to crunch gigabytes or petabytes of data. Yeah. Yeah, with that, thanks a lot. And those are the two links for the articles upon which this talk is based on. So if you're interested, you can go ahead and read them online. Thanks a lot.
Thank you.